Hey everyone, and welcome back to Brave Fusion. I'm Anish, and today we'll be solving a very good question on engineering mathematics. This is from the calculus topic. This came on the EE branch, from the EE branch of GATE 2024. So, what is the question telling us? The question is telling f of t is a real valued function. Okay, it is real valued function whose second derivative is positive for t negative infinity to positive infinity, but it does not include these 2 points. Okay, negative infinity and positive infinity. Now it is asking us which of the following statements is or are true. Okay, before reading the statements, I want to decode what the question has told us. It has told that we have a function f of t and its double derivative is always positive. But before tackling this, I want to tackle that what does like derivative of a function positive means. So let me take another function g of t. Let's say I have a function g of t. Okay, and its derivative is positive. If its derivative is positive, that means its slope is always positive. For t from minus infinity to infinity, its slope is always positive. Okay, the slope is always positive. So what we can say? What we can say is, let me draw two graphs, and from there we can understand what do you mean by slope is always positive. Now here, this is one. Let me draw this graph. Okay, let me draw this graph and this graph. Okay, like this has constant slope, this has what, slope reducing and then increasing. This has slope increasing here, right? Slope reducing, and then here it is slope increasing, but this is not always positive. Now what will be always positive? Always positive will be something like this. When it is like this, so here I see my slope is always positive. Slope is always positive, right? Slope is always positive. Here also my slope is always positive. So this function is always increasing. This function is always increasing, but this function isn't always increasing. Sometimes its slope is negative, hence it isn't always increasing. So by slope always positive, we mean that function will always increase because the differentiation is positive. Like the differentiation is positive, hence what I will say is g of t will always be a increasing function. Okay, so this is the first thing. So if the derivative of a function is always positive, that means it is a increasing function. Now here in our case, this is not the derivative, this is a double derivative. That means the derivative of f dash of t is always positive. That means the slope is always positive. Okay, so not the slope, this derivative of this is always positive. That means slope of f of t, what is this? What can we say in words? This is slope of f of t. Okay, derivative of f of t is always increasing, as its derivative, slope of f of t's derivative is always positive. Hence this is slope of f t is always increasing. So this is what we can decode from that statement. Whatever statement they have given us, this is what we can decode. Now let's read the statements. So read the options. This was a MSQ, like as I got the information, this was an MSQ. The first option is the minimum value of f of t cannot be negative. The minimum value of f of t cannot be negative. Now let's check. I will take one example. I will reject those, reject the options. So here, first thing is my slope is always increasing. Okay, I will choose one graph whose slope will be always increasing. Okay, so this slope is always increasing. Okay, if you see here, slope is negative here, but it is slowly going towards 0, so it is increasing. Okay, it is going increasing. So here slope is always increasing, and what is, like, let me name, write the function f of t equals to t square minus 2. Okay, t square minus 2. So if you do the double derivative, it will be 2, which is always positive. Okay, and its minima value is here, right, negative 2. Like at t equals 0, it has minima. So yeah, minimum value is 2, but here it is telling the minimum value cannot be negative. So this is wrong. We have to choose the correct option. So A is gone. Now second option, has at least one local maximum. has at least one local maximum. Now for something to have maximum, what needs to happen? So let me take this function. So here I see, yeah, this has a maxima, but what is the problem here? The problem is slope is starting to reduce. So every time near the maximum point, the slope will always reduce because it is the maximum point, local maxima. So slope will always tend to reduce before and after it. Okay, so obviously this is not possible. My slope is always increasing. So this option is also gone, that it has at least one maxima. No, it can't have a maxima. Because my slope is always increasing. Okay, and for a maxima to happen, the slope neighborhood to that should be decreasing. Okay, it is always increasing. So hence my option B is also gone. Now the third option, f of t cannot have two distinct local minimum. So before going to this, I forgot to tell you one thing, that if f double dash of t exists, right? F double dash of t exists and it is greater than zero, that means my f dash of t also exists, and that means my f of t also exists. Okay, like it is always continuous. So if f double dash of t is continuous, it is greater than 0, then f dash of t will be continuous and f of t will be continuous. Now what does this mean? This means f of t is continuous and f dash of t is continuous. That means my f of t is continuous and differentiable. So this is the meaning. Now if it is continuous and differentiable, so it can't have a sudden change in its slope or sudden change in its value. Okay, sudden jump it can't have, sharp turn it can't have, all those things it can't have. Okay, so let me take the option C. It is telling that it can have, what is the option? F of t cannot have two distinct local minima. Let's say if it has two distinct local minima. Let me take the example. So yeah, this example I can take, okay, with a twist. This is t, this is f of t. Now you might think that my slope should be always increasing. Okay, and what if I take this function? Okay, so here my slope is always increasing and suddenly there is a sharp turn here. Okay, the change in slope is sudden, then again slope is increasing. So slope is always increasing and I have two local minimas here. But is this true? Like this function is not valid for in this case because the double derivative exists for this. Okay, like always, as is in the question mentioned, but for this it doesn't exist because the derivative doesn't exist for this. Okay, that's why. So we can't take these types of function. So for two local minimas to happen, it has to be something like this for two local minimas to occur. But if the function is something like this, then a maxima will occur between two local minimas. There will be a maxima, and maxima cannot occur. We have already established in the option B. So option C is like correct because it has told that f of t cannot have two distinct local minima. So option C is correct. It cannot have two distinct local minima. It will have one, or it can have 0 as well. We will verify this in the last option. So the last option is telling that f of t has at least one local minima. Now what I will do is just take a simple example of e raised to power x. Not e raised to power x, e raised to power t. Okay, so if I take this example, the double derivative of this is simply e raised to power t, which is always positive, for any values of t. Okay, so here what we see is it is always increasing, but does a local minima exist? It doesn't have any local minima. Okay, e raised to exponential function doesn't have any local minima. Okay, this e raised to power t. Hence, still this is this is a function that has always slope increasing, double derivative greater than positive, or its slope is always increasing. So it can have no local minima as well. Okay, hence this last statement is wrong because here it states that f of t has at least one local minima, which is not true. It can have no local minima as well in this case because local minima isn't defined. E of t will be minimum at t tends to infinity, minus infinity, which is not included in our range here. Okay, so that's why it doesn't have any local minima. So the answer for this question, which I believe will be only the option C. Okay, all of the other options will be cancelled, but this was a MSQ, so let's see what they give out. But according to me, the answer for this will be only option C. Okay, so yeah, thank you for watching and I will see you in the next video.